Hey everyone! Welcome back to Bugnojutsu. In today's video, we're going to solve a really interesting LeetCode problem called Alice and Bob Playing Flower Game. This is one of those problems that look simple at first, but once you think deeper, you realize there's a nice mathematical trick hidden inside. So let's break it down step by step and make sure you understand both the intuition and the solution clearly. So here's the setup. Alice and Bob are playing a game with two lanes of flowers placed between them. In the first lane, there are X flowers, and in the second lane, there are Y flowers. The rules are straightforward. Alice always goes first. On each turn, the current player must pick exactly one flower from either lane. The game continues until all flowers are gone, and the player who removes the very last flower is the winner. Now, the challenge for us is, given the ranges of flowers in both lanes, specifically 1 to N flowers in the first lane and 1 to M flowers in the second lane, we need to count how many possible X, Y combinations guarantee that Alice wins the game. Let's make this concrete with a simple example. Suppose N equals 3 and M equals 2. That means the first lane can have anywhere between 1 to 3 flowers, and the second lane can have between 1 to 2 flowers. Now, we need to list out the valid pairs, X, Y, that allow Alice to win. If we carefully check, the pairs 1, 2, 3, 2, and 2, 1 work out in Alice's favor. So in this case, the answer is 3. What's really important to notice here is that Alice doesn't always win. It completely depends on whether the total number of flowers is odd or even. Here's the main insight. Every move reduces the total number of flowers by exactly 1. So if the total number of flowers is odd, Alice will always be the one to take the last flower, because she starts first. On the other hand, if the total number of flowers is even, then Bob will always get the last flower. So instead of checking every single possibility one by one, what we really need to do is count how many X, Y pairs give us an odd sum. To make this counting easier, we can break the numbers into two groups, odd numbers and even numbers. If one lane has an odd count and the other has an even count, then their sum is odd, which means Alice wins. So the final calculation is straightforward: number of odd values in the first lane multiplied by number of even values in the second lane, plus number of even values in the first lane multiplied by number of odd values in the second lane. This shortcut lets us solve the problem instantly instead of looping through all possibilities. Now, let's quickly analyze complexity. Since we are only doing simple arithmetic calculations, counting odds and evens, the time complexity is 1. That means no matter how large N and M are, the solution runs instantly. As for space complexity, we're only using a few variables to store counts, so it's 1 as well. Very efficient compared to a brute force approach. What makes this problem interesting is the shift in thinking. At first glance, it feels like a simulation problem where you would loop through each pair and try to play out the game. But if you take a step back, you'll notice that the only thing that matters is the parity, the oddness or evenness of the total flowers. Once you spot this pattern, the problem transforms from a looping brute force approach to a neat mathematical shortcut. This kind of thinking is really valuable in competitive programming. Instead of brute forcing, always ask yourself, is there a hidden pattern here? More often than not, these problems can be cracked wide open with a bit of number theory or parity reasoning. So that's the complete breakdown of Alice and Bob Playing Flower Game. I hope this explanation made the problem clear and gave you a new way to think about such game-based puzzles. If you found this helpful, don't forget to like the video, drop your thoughts in the comments, and of course, subscribe to Bugnojutsu for more problem-solving insights and breakdowns. Thanks for watching, and I'll see you in the next one.